Hey, what's up, biotech students? So today we're going to be looking at molar mass. So we talked a little bit about the mole, and we learned that, okay, 1 mole is 6.022 times 10 to the 23rd particles or molecules. It's just like a dozen. So no matter what element or what compound we're using, Avogadro's number tells us how many molecules there are. But our first big focus is going to be just on the molar mass. So how many grams are in 1 mole? And it's going to be different depending on the compound or the molecule, but the molar mass, our unit for molar mass is going to be grams per mole. So just how many grams are in 1 mole of the substance. So let's start off talking about, I want to erase this. Okay, I'm just going to kind of put our unit over here, grams per mole. So let's talk about oxygen. All right, well, oxygen, if we look on the periodic table, it's right here, and I know you can't see this, but it's 15.999. So we'll just say 15.9. We often just round this to make it easy. So if I was to round this, I would round it to 16. So 1 mole of straight oxygen, the mass is 16. I got that from this periodic table. The problem is, oxygen does not exist like this out in nature. It exists like this. So this is a different molecule of oxygen. And the molar mass of this, because there's 2 oxygens, okay, I'm going to do 16 and 16. I'm going to add the molar mass twice, right? This has a molar mass of 32 grams per mole. So just regular old oxygen had a mass of 16 grams per mole. Oxygen gas that we breathe in, O2, has a molar mass of 32. Well, ozone up in the upper atmosphere has 3 oxygens in this molecule. So it would have a molar mass of 48 grams per mole. So the molar mass of different molecules is going to be different. And we get it by just adding the mass from the periodic table as many times as it says we should. So I'll do a couple more examples here. Let's just do, let me think about, all right, let's say NaOH. Right, so I have 1 sodium, 1 oxygen, 1 hydrogen. So look at my periodic table. The mass of sodium is roughly 23, oxygen 16, H is 1. So to find the molar mass, I'm just going to add these up. What's that? 49 grams per mole. So I had 1 sodium, 23, 1 oxygen, 16, 1 hydrogen, 1. I just add them up to find my molar mass. What if it was a little bit harder than that? Okay, so let's say MgOH2. So now we have this 2 here, and what this means is we got 2 OHs. We got 2 hydroxides. We got 2 of these, right? So you got to double both the oxygen and you got to double the hydrogen to get your molar mass. So looking at my periodic table, magnesium has a molar mass of 24. Oxygen is 16, hydrogen 1, oxygen 16, hydrogen 1. All right, so I'm going to add these things together. 32, 36. I think roughly, if my math in my head is correct, we get something like 58 grams per mole. Right? You could also say, okay, well, oxygen and hydrogen together, right, is 16 and 1, which is 17. So I could double that. I could say, okay, well, magnesium's 24, this is 17, and this is, so I'm going to do 2 of them. I could have added it together that way. So there's kind of several little tricks you can do to figure out your molar mass. You just want to do whatever you're comfortable with. So that's it. We're just going to look at our chemical formula, whatever that chemical formula may be. All right, SF8. So I'm going to look at my chemical formula for each individual. We know this is 2 things because there are 2 capital letters. So a capital letter signifies that it's a new or an element on the periodic table. S is 32. F is 19. Right? But there are 8 Fs. There are not 8 sulfurs. If this looked like this, now there would be 8 fluorines and 8 sulfurs. But because there's no parentheses, the 8 only deals with the F. So I would do 19 times 8, add that to 32, and that would give me my molar mass. All right, so I hope that helped you figure out how to calculate your molar mass. That's it for today.